Thanks, everybody. I have a bunch of fun things to tell you about. In fact, the big news is that we're going to announce the winners of the Afron $10 Robot Design Challenge at the end of the talk. So, but before I do that, what I want to do is first of all, take you back in time a little bit to 1993. Let's see. To 1993. And some of you will remember the birth of the World Wide Web. So when my students and I saw this, we got super excited about the possibility because we were working in a lab that we're doing robotics, and we started thinking, what if we could connect a robot to the internet? So we wanted to do an application that would get a lot of attention, get people to come in and try it. So we thought, well, we would build blocks or something like that, but then we struck on the idea of a garden. So we built this thing we called a Telegarden. And it was a real living garden with about 18 inches of soil, plants growing in it, a robot, and then a web interface so that people anywhere in the world could log in on their browsers, and then they could log in, they could move around, they could move the robot, they could zoom in and look at the plants. But if they wanted to register, they could also start to participate by watering the plants. And then they could also go in, and after they watered for a certain amount of time, we then granted them permission to plant their first seed. So people could start planting seeds and watering them. And actually, just outside, I saw a group that was down to a hydroponic garden that's connected, so anybody can have a kind of variation of this at their home. But this was almost 20 years ago, and the idea was we were really excited about the idea of using the network as a way to engage large numbers of people and being able to share control of robots. Now, a lot's happened since then, and most of you know about Mars Curiosity, a hugely successful, brilliant piece of engineering that just landed on Mars. And it's also a telerobot in the sense that it's being controlled not by the general public yet, but by experts in NASA. But people in robotics, my colleagues in the research field, see a trend. We see that over the last 10 years, there's been a real inflection point in the adoption rate of robots. So many of you have Roomba robots at home. There's now about 5 million of them out there. There's many defense robots. There's a huge number of surgical robots appearing on the frontier. And actually, there's been some real attention and the appreciation for this whole field from some very important people. For example,
you might not know this, but one of my responsibilities as Commander-in-Chief is to keep an eye on robots. And I'm pleased to report that the robots you manufacture here seem peaceful, at least for now. To help everyone from factory workers to astronauts carry out more complicated tasks, NASA and other agencies will support research into next-generation robotics.
So this is a huge announcement that was made about a year and a half ago, and a major new initiative called the National Robotics Initiative was launched. So there's a lot of new research that is going on in robots here in the United States. And I also want to mention that it's also affecting popular culture. How many of you have had a chance to see this film, Robot and Frank? It just came out this year. If you haven't, I highly recommend it. It's a really interesting, insightful view. I think it's actually something about the future of robotics. I don't want to give anything away because it's just a fantastic story, but it also shows an element, the key element is that it really suggests a role of companionship between people and humans that I think we're going to see, hopefully in our lifetime. Now, what I want to talk about is a particular phenomenon. How many of you know about the Google car? Right? Almost everybody's heard about that. And what's interesting about the Google car is that it's not just it's not just everything happening on board. What's interesting is that Google is doing it because this Google car makes use of the network. In fact, it integrates large amounts of data that's being collected both by its own cars, but also by all of us. As we drive around, our data is being collected, our location information, and that's being integrated into a system that allows this robot to very precisely localize its position at any given moment in time. I like this quote from Brad Templeton, who said, "A robot will be truly autonomous when you instruct it to go to work and it decides to go to the beach instead." We're not quite there yet, but there's something really interesting happening now. Just last week, California signed into law legislation that's going to allow autonomous cars on the roads. And the term that roboticists are starting to use for this broader idea is cloud robotics. And what we mean by the cloud is the internet, right? All the different aspects that are associated with it. And the reason this is powerful is that let's take a problem that people have been interested in for a long time, which is not just having a robot go around and sweep up the floors, but a robot that could, let's say, pick up, declutter a house. And any of you that have kids know that that would be really nice to be able to have. The problem is that a lot of times the robot's going to encounter things it doesn't know, right? Because you can't store that much on a robot because it has to drive around. So how do you deal with that? And the new idea is that we make use of the internet. So when you see something you don't know, the robot can take a picture of it, go online, and get access to gigabits, terabytes of information about almost every product that's out there. And it can index into that to find out information about its shape, etc. The other idea is that the robot can make use of the vast computing power on the internet. So you don't have to carry all of your computing on board the robot. The robot on demand, when it wants to do a complicated calculation, like motion planning through a complicated environment, it can index and quickly access thousands of computers. And the other thing about this cloud robotics is the open sharing of information. And that's what I'm going to come back to at the end about the Afron Design Challenge, which is that for the first time in my career in robotics, in the last 5 years, people have started really exchanging code and data openly. So there's now open source toolkits for robotics that is vastly accelerating the progress of the field. Now, these kind of tools are, with databases, computation, and the sharing of software, that's going to do a lot, but every once in a while, the robot is still going to get stuck. It's going to encounter something it's never really sure what to do with. And when that happens, we can still use the network. Because we can, for example, imagine the robot would call a call center where a human would be standing by. And then the human could answer and say, oh, well, that's a Rubik's Cube. It goes in the toy area, right? So it sort of reverses the usual relationship between the robot and the human, but it's a very interesting idea that it's not so far-fetched, that we could have operators for the rare occurrences when the robot really gets stuck. And here's another scenario I like. It's related.
Can you fly that thing?
It's from The Matrix.
Not yet.
She doesn't know how to fly the helicopter.
I need a pilot program for a B-212 helicopter. Hurry.
Can you crank it up? Cool.
Let's go.
I love that scene, right? So she doesn't know how to do it, but she can download the information. The robot can download software on demand. And all this is summed up by a great phrase that Steve Cousins of Willow Garage stated recently, which is, no robot is an island. So this is a new paradigm, a new philosophy for robotics. We're not thinking about it as robots individually moving around, autonomous beings, but they're actually sharing information via the cloud. Now, how is this going to work? It's very complex, and there's a lot of different ideas and approaches that researchers are developing for this in the research community, and there's a number of papers that you can read about different ideas that are starting to emerge on this. I want to tell you about one specific area that's coming out of our lab at Berkeley that we've been collaborating with Google on a project that involves that tries to address the subproblem of just grasping parts that I hinted at earlier. So robot grasping is a hard problem. It's something humans, even babies, do very naturally. But for robots, it's hard because it's very hard to reason about the geometry and the physics of parts. So our idea is the following. We're going to make use of a piece of software that Google put out for free a few years ago called Google Goggles. And it's free. You can download this at any time. And it allows you to basically take a picture of something, like a famous landmark, and then it'll index into its image store. Google will do this offline, and then download for you websites that will describe that object. Now, this works nice for landmarks, but you can also do it for household objects, particularly like consumer products. You can aim it at something, and it'll look up and it'll tell you about that consumer product. So it's incredibly powerful to just be able to index things by taking pictures of them. So here's our idea. We're going to have this capability integrated with a robot arm. And, for example, it might look down and see this object. It's not sure what it is. It takes a picture of it, sends that picture up to the cloud, and then in particular to Google's tool, which indexes that using vast libraries, And that Google will come back and say, here's the object, here's the 3D geometry, here's the frictional properties, the center of mass, etc., that will help the robot in lifting it up and grasping it. The other part of it is that Google can store with that object a whole set of pre-computed grasp strategies. These can be done offline so that when the robot needs to pick that up, it can just index into them. It doesn't have to recompute them on the fly. So here's the idea. The robot picks that thing up successfully. And there's an offline phase, which actually we're all participating in right now. Every time we take a picture and we use Google search and we click on a particular solution it's found something we're looking at, a cat with robot, and we click yes, that's a cat. Google makes use of that to enhance its machine learning around all of its image libraries. So that's what the humans do. We put in all kinds of information, and then the robot online makes use of that by taking the images, indexing into that vast database, taking the data back down, and then making operations with it. So we've done some of this in the lab, and we've done some experiments with some household objects you may recognize, and here's some of the results. We're actually finding that we're able to take images of those pictures, of those objects, with the robot, and we can estimate the position of the object with about, it only fails about 8% of the time, and then we could grasp it, and it only fails about 13% of the time. Now that's not perfect, and it's really not enough for a household robot, but we're making progress. So it's a step in this new direction of taking tools that are out there that are actually human-enhanced, that take advantage of all the data that's flowing out there, and using it to help robots. Now I'm going to shift gears. I want to tell you about another aspect of the cloud, which is where we're making use of the vast resources of human ingenuity that is out there in the cloud. And I was born in Africa, and I went back to Africa to Ghana last spring. And it turns out I met a number of people there who are interested in robots, actually many different groups. And they have the strong interest in using robots to teach. But for example, they're using the Lego Mindstorms, which is $250 or so. It's a great system, but it's very expensive. So we decided to form a group. We called it the African Robotics Network, AFRON for short, and we put out basically an announcement about this. Our motivation is to connect people with interests in robotics across Africa. And we wanted to develop robots for education to inspire students, basically very similar to the whole mission of the Maker Faire. And it turns out that there are groups that are doing this in different parts of Africa. And so we formed an advisory board, and I'm doing this in conjunction with Ayorkor Korsa, who's a professor of robotics at Esseshi University in Ghana. We have now about 300 members from many different countries around the world, and it's growing. And by the way, any of you can join. So you can be an affiliated member if you don't live in Africa, or if you don't have close ties to Africa. And also institutions can join. So we have a couple of institutions, different universities and private organizations within Africa who are members. And then our big project this year is the following. This is the $10 Robot Design Challenge. And the idea is, can we design an ultra-affordable robot for education so that students could have their own robot, essentially? And we set a target of $10. We didn't think anybody could ever achieve that, but that was something that we just thought we'll put out there as a goal, that we'll see, can we get something that gets even, within $50 or $100 would be a big step forward. So we raised some money for some cash prizes from the IEEE, and we also got Raspberry Pis from one of our board members, and we put out an open call in June. The criteria are practicality, creativity, and cost, and the submissions were due on September 15th, 1 week ago, or 2 weeks ago, and take note of that, because we're going to post all the information on the website as of 6 p.m. or tonight. But I'm going to now reveal the winners. First, I'm going to tell you that this is a jury. So we had a wonderful jury of 6 experts from different parts of the world who judged them. And we got 28 fantastic submissions by the deadline. We reviewed them very carefully, and we now are ready to announce 10 winners. So they are the following. We have 3 categories. The first one is the all-in-one category. So this is a self-contained robotic system. And the first one is a group from Brazil who designed something they call the N-Bot. And what's beautiful about this is it costs about $14 in parts, excluding the phone. But the idea is, can you get a hold of, increasingly there's going to be surplus phones available. So right now we estimate that's probably going to cost you about $50 to $100 to add the phone in there. But the phone has a lot of computing power. So the beautiful idea is that they can take the phone, do all the programming on that, and then just be able to plug that in to this mobile device that can then move around and perform operations. Second prize in that category goes to a group from India who have developed a set of robots called Knitbots. And these it's a beautiful toolkit. It actually contains all the parts, and curriculum for allowing you to do experiments with them. So they really address the educational component. There's a toolkit for fourth grade to sixth grade that involves plastic parts, and then from 7th to 12th grade that involves metal parts. And they provide all the programming, there's all the components, the breadboards, the batteries, everything else. Those are not quite as cheap. They come out to about $33, but still pretty reasonable. The next category is the traditional, what we call the traditional roaming robots. These are robots that can roam free. And the fourth prize goes to Discbot. This is an American developer who designed this. It's a beautiful design, all parts that are laser etched out of wood that he will put together and sell as a package. And this will retail for about $47, although the price will come down in volume. And this is a group from MIT who designed a robot designed based on origami principles. And it involves plastic elements that are folded to achieve strength. So here's a picture of it moving around. And this robot, the SEG robot, as I call it, is $14.09. The next winner is the Swarmbot, and this came out of a group in China. Here's their lab. So they have a lot of kids and students and people who come together in Shanghai and build and design things, again in the spirit of Maker Faire. And what they designed was something called the Swarm Robot. This is an example. Again, all the parts are very small. This sells for, they actually reached the goal, $9.51. And they also not only designed one, but they designed a whole family of different variations of them. Again, all using very, very low-cost components. And the first prize winner in this category is something called the Kilobot. And this is beautiful design. It comes out of a group at Harvard, and there's no wheels, no legs. Basically, those are just pins, and the way it moves is by vibration. So it's by controlling its vibrational modes, it can basically scuttle across the floor. And what's also cool about this, and these actually are surprisingly expensive given they're about $43 each, but they'll come down to $14 in volume. So about 1,000, if you can make enough orders to get 1,000, you can get them down to $14. But what's also cool about these is that you can have lots of them. And they're very interesting to explore swarm behavior, group behavior of robots. So you have a global, let's say, LED system here that they also make available, and then as these light up, the robots then respond to them. So you can watch different swarming behavior. And by the way, there's a lot of videos that'll be available on the website to show you this in action. So now I want to get to the last category, which is tethered. What we mean by that is that these robots are still going to have an attachment to a motherboard, a mothership, which will probably be a computer, a laptop. But that can provide power, but more importantly, it can provide sensing and programming. So the fourth prize here goes to a group from Nigeria who developed something called the RoboArm. And it's a little hard to see from this picture, but it's all made of plastic laser cut parts. And it has motors and a gripper on it, so it can actually go around and manipulate. They were the only ones who were able to generate a manipulator rather than a mobile robot, and that sells for $50.44. Here's one from a gentleman in the United States. It's called the Acrobot, and you notice that it's made with some nice materials. This is made with cardboard and zip ties. It's a beautiful and elegant design, and this sells for $9.94.
Robot, start.
Oh, I should mention it has voice commands.
Robotic. Stop.
So that is it's a beautiful piece of work, but only, again, $9.94. The second prize goes to another group from the United States that designed the Bowbot, which is a very elegant robot with these long elements that are basically feelers that can use to touch to determine if it's made contact with things in its environment. It has a very extensive curriculum that goes with it. And now I'm ready to announce the first prize winner. And, well, actually, here's another shot of the Bowbot. So I feel like there should be a drum roll because this one really, the first prize winner really blew me out of the water. And it's not what we expected. What this gentleman did is he's a student. Sorry, he's associated with the university in Thailand, and his idea was to make use of a game controller. And these are very commonly available now. You can get them surplus for about $5 or $6. Now that thing that's not a robot, but he came up with the idea that it has vibration inside. So there's motors built inside. So he decided that if he took out the motors, he could refashion them into actually driving wheels. And moreover, once he can move that around, it also has an issue that he wants to be able to detect things. So he wants to use basically use these switches, the thumb switches, to detect contact. So he has to have an inertial sensor that will basically react when it bumps into something. So you need to have some lever arm on top of those thumb switches. So the way he solves that, brilliantly I think, is with lollipops. And he has installed, this is our grand prize winner. This comes in at $8.96. It is a beautiful self-contained robot system that can move around and respond. It's tethered, but let me show you a little video. This is his music. Okay, so you get the idea. It's a brilliant piece of design and engineering, and I have to say, they really surpassed anything that we could have hoped. And the surprise that someone in Thailand would have come up with the best idea that we saw was just a beautiful example of the cloud at work, because we don't know where the next great idea is going to come from. It's going to come from somewhere in the world. And what we're very excited about, the next step is to make these available, and so we're going to post all the information online. For example, the Suckerbot has incredibly detailed directions. You could do it yourself. So anybody anywhere in the world can build their own. And then we're going to be finding a couple of these that we'll be supporting by actually providing more software and repositories, basically, so that others, as they develop extensions and enhancements to these robots, be able to post them online so people can share them and develop more and more curriculum around them. So this is a new idea, and we're very excited about the potential of how designers all over the world can come together and come up with solutions to really complex and challenging problems like this one, and come up with solutions that you would just never think about. Thank you.